Hey guys, let's go over D2. Solve each system of equations algebraically, then verify each solution graphically. So we're going to solve the systems by substitution. How did I know by substitution? You'll notice that both those equations, the quadratic with the power of 2 and 1 to the first power, are both equal to y. So let me go ahead and write down those problems below, and we can work on this. So I have y equals x squared minus 3x plus 1. And I have y equals x minus 3. Just section off our work over here. Okay, so what can we do? We said we're going to solve these by substitution, okay? So I'm going to use my highlighter. If you have a highlighter, super helpful. Every time we see y, we can write x minus 3. I see y here, and so instead of writing y, we can write what? X, try that again, x minus 3. On the right side, everything just stays the same. So we just did substitution there. And I'm going to use the steps from the previous problem. We can now solve the quadratics. How do you solve the quadratics? We're basically going to move everything on the left side to the right. Why? Because we're trying to get it set equal to 0. Okay, so let me draw a straight line down the middle. That kind of shows the left and right side, right? So let's do the opposites, the inverses. Try that again. So opposite of positive x is a negative x. That goes right there. And opposite of negative 3 is a positive 3. Goes right there. Kind of just doing two steps in one. So this equals 0. That equals 0. We are left with x squared minus 4x plus 4. And again, we're trying to solve this quadratic. So the best way of solving is by using factoring. So let's see if we can factor this. Super happy, right? A times c is 4. My b value is negative 4. My two numbers that multiply to be positive 4, but have to add to be negative would be negative 2 and negative 2. All right, so that gives us 0 equals x minus 2 and x minus 2. Okay? Then our next step is use something called the ZPR, which just basically says square times the triangle over on the left side equals 0, which implies that one of those has to be 0. So I'm going to set both of these here equal to 0. Now, it sounds kind of weird, but you have the same problem. So why would you do the same problem twice? They call this a double root, and you'll kind of see why what happens. So if I add 2 here, x equals 2, and you have x equals 2. Kind of weird, right? Why would you have it twice? Now, next step is to sub x to get a y. So let's go ahead and substitute in x into a y. What am I going to use? Let's use our highlighter over here, and I already have up here y equals x minus 3. So I'm going to substitute in x equals 2 into this equation right there. Okay, let's do that. So I have y equals the 2 that we saw from below, the x value, minus 3. And this will give us y equals negative 1. So that step we said down here is in number 5. It's an order pair. Okay, so let's put those together. The order pair is 2, negative 1. 2, negative 1. Now, if you did it twice, you would get the same order pair, which basically means they're going to intersect at the one place. They're going to intersect at one place. Now, I didn't show this in the last problem, but if in the new problem here, if you do something called the discriminant, and it's greater than 0, you will have 2 solutions. Okay. If it is equal to 0, you will have 1 solution. And if you have it a number smaller than 0, negative, you're going to have 0 real solutions, if you think about it. Okay. So the reason why this works, let's do it on ours. Again, I'm using that one right here. So my b value, let's write down formula. And our b value from above is negative 4 squared minus 4 times 1 times 4. So I have 16 minus 16, which equals 0. And that means there's only, because it's equal to 0, there's only one solution, which we have right here, 2, negative 1. Okay? Let's make that super obvious. Is that green? I like green. There it is. Okay? Now let's verify that graphically, okay? So there's my y, there's my x. Let's graph the linear. You'll notice that this is in the form of y equals mx plus b. So my b value is negative 3, so let's go ahead and find that. Let's up a little bit. Negative 1, negative 2, negative 3. Okay. And my slope here is 1, which means it is 1 over 1, which means a rise of 1 and a run of 1. What does that mean? Up 1, right 1. That's how you graph slope of linear equations. Let's do it together. Up 1, right 1. Boom. Up 1, right 1. You can do that all day long. Here, I'll do something crazy. Ready? Left 1, down 1. That's negative 1 over negative 1. It's still positive 1. Is that crazy? Alright, so let's see. This is our graph in orange. Let's do our best. There it is. Okay, now let's graph the quadratic. Do a little math on it. Okay, so this one's a little bit tricky because if you do the factoring, you'll get 1 and then b value negative 3, and there's no values, which means it's not factorable. Okay, what does that tell us? I do know one point. Let's go to this one point over here. 2, negative 1. We already know that we have something at 2, negative 1. So let's write that. 2, negative 1. I already know my answer is going to be there. Write 2, negative 1. There is my solution. But how does my graph go through there? So this is in standard form. Ax squared plus bx plus c. And we have a y-intercept of 1. There's my y-intercept. Okay. The a value is positive, so positive people smile. So it's going to graph up. Okay. So we need to go through there and go through it once. And do we pick a color? Let's do blue. Okay, so let's graph that. How does it go through once? Because then maybe those orange will never, and the blue won't intersect. But the big idea here is that the intersection is right here. That is the order pair 2, comma, negative 1. So this problem you have one solution. Okay? See you guys.